Hello, I am Yalko. As a YouTuber operating a channel called Coding with Yalko, I work on explaining difficult coding concepts in a simple way. The topic of the lecture I'm presenting this time is React. Through abundant visual materials, crisp explanations by analogy, various examples, and a high-quality final project that contains real-world development, I'll teach you React programming more easily and quickly than any other content. You can watch the first hour or so for free through a YouTube video. The main content and the final project can be taken on the platform linked in the pinned comment. I've prepared to the best of our ability to make a course worth your time and money. I hope it's a valuable and enjoyable class for all of you who take it. Now, let's start with the easiest React. In this video, I'm going to tell you why you should learn React to become a front-end developer. React is one of the most used tools in the front-end development industry today. Many famous websites and apps are made with React. Places like Facebook, Instagram, Netflix are all using React to assist users to conveniently and quickly use the website. Compared to other front-end tools that can be seen as competitors, such as Vue, Angular, Svelte, etc., you can see that React has the highest market share. As such a widely used technology in the industry, learning React is a great advantage as a developer. Not only is it advantageous for employment, but there are also plenty of educational materials available for study, making it easy to learn. What could be the reason why React is so widely used? The first is reactivity. Before the advent of systems like React, a web page, almost all user actions were conducted through a refresh. On such a page, even if you click the like button, the whole page would blink and reload in the process of changing the color of the button. The reason is as follows. The web pages we see are like how word processors read document files. Browsers such as Safari or Chrome get HTML documents and related files from the server and then execute and display them. In the early websites, when things need to be modified, such as when the user clicks a button, it had to send a request to the server and execute all the resources again. Therefore, the user had to put up with the inconvenience of the entire page being refreshed just to see the look of a small button change. However, after the introduction of technology such as Ajax and the creation of tools like React, when a user clicks a button, the browser sends a related request to the server. The server only sends the data needed to modify the button to the browser, and the browser uses JavaScript to change just that element. Therefore, users can enjoy a much more pleasant web surfing experience, and they can now enjoy powerful and convenient features like infinity scrolling. The second is reusability. Early web pages were written as a single HTML document like this. If some elements constituting this page are used on other pages, you had to copy the code of that part and write it in a new document. This not only duplicates codes, but when the element needed to change, there was the inconvenience of having to find and correct the corresponding part in all documents. Front-end libraries and frameworks of today, including React, allows you to break down the elements of the website into parts called components. You can separate each component into reusable parts and distribute them into different files. By using these components in combination where necessary, you can reduce code duplication and significantly simplify maintenance.
But can't we implement this reactivity and reusability without something like React? We can create all those things we just talked about by just using JavaScript, right?
Yes, that's correct. However, if you're only using JavaScript, you'd have a lot of work to do. I'll explain it to you through the rest of the reasons we'll be discussing from now on. The third reason to use React is JSX. Let's assume you're implementing a certain element of a web page. It's a simple counter-type component where the numbers increase when you click the button. If you write this in pure JavaScript, you get a code like this. As you can see, it's a verbose code where JavaScript creates HTML elements, inserts values and events, and adds them to the page. If you write this in a React-specific syntax called JSX, the code will be like this. Although you haven't learned JSX yet, this code is much more concise, and you can more intuitively guess the component and its function you want to create.
It feels like a mix of JavaScript and HTML, doesn't it?
Right? Because React programs using this JSX syntax, it allows you to write code that is much more concise and readable than pure JavaScript. The fourth is a characteristic feature of React, the virtual DOM. To explain this concept, you need to first know about the DOM. I will include a separate video for you to watch the DOM if you wish. Here, I'll just use a simple metaphor. As mentioned about reactivity, without refreshing a web page, dynamically changing elements on the web page requires more computation than you think. It's like placing cars of different sizes in a parking lot. Let's assume that all the spaces between cars must be exactly the same. Each car would have to move forward and back, measuring the gap with the car in front, in order to park. It would take a lot of time and effort to position all the cars. If this parking lot and cars are DOM, the virtual DOM is like a reduced scale model of each with exact proportions. Using this model to first arrange and marking where each car will park based on this, then directing the cars to park in the marked locations would speed things up a lot. After watching this video, you will understand this analogy much better. Before the browser manipulates the actual DOM, React implements a virtual DOM in JavaScript to finish the necessary calculations beforehand, and then only the DOM that actually needs modification is manipulated, enhancing the performance of the web page.
So, we don't have to code all these things ourselves in JavaScript. You're saying React has implemented all of this in advance?
That's right. In addition to what we talked about in this video, by utilizing numerous powerful features of React, you can easily create a high-quality web application. Thus, we have examined why we should learn React. In the next video, we will install what we need for practice together. Now, we are going to install and set up the necessary programs for our practical sessions. The first thing we will install is something called Node.js. Node.js is a tool that allows you to give commands to your computer using JavaScript. You may think of it as a program that translates the code written in JavaScript for the computer to understand. JavaScript was originally a language that only works in browsers, which are programs used for web surfing like Chrome, Edge and Safari. So, it was a language that could only be used and operated within websites. With Node.js now able to read JavaScript, a language that was only readable by browsers, we can now use JavaScript for various purposes, such as server, desktop programs, and command line tools.
Why do we need Node.js when what we're going to create with React is also a website?
We will be writing our code using a syntax called JSX, but the browser doesn't understand this, meaning we can't directly use code written in JSX, not JavaScript, on a website. This work of translating it into JavaScript, which the browser can understand, is done through Node.js. The Node.js installed on your computer uses a program written in JavaScript to translate JSX code into JavaScript code. The compiled JavaScript is executed by the browser, making the web page work. Not only that, but many tools that run on Node.js will also help our programming. It automatically creates projects with basic codes needed for React development, downloads and installs various libraries used to create web pages based on React, and runs a server directly from my computer so that I can see the web page I am coding in real time. These powerful tools, which greatly relieve the efforts of React developers, are designed to run on Node.js. Installing Node.js is not difficult. First, access the official site at this address, and you can download the LTS version of Node.js by pushing this button. The LTS version, unlike the latest version, is relatively safe and promises long-term maintenance. Please install it by running the downloaded installer. We recommend those who have previously used Node.js to re-download and update to the LTS version if possible. The next thing to download is VS Code. Actually, if you're going to learn React, you probably already have a web development editor or IDE. These days, there are tools that utilize AI like Cursor. Although we use VS Code in this class, you don't have to do the same. Those who want to use VS Code should also visit the official page to download and install it. After completing the installation, if you run VS Code, you will see this initial screen. Then, on the menu bar at the top, click Terminal, and then click on New Terminal. Then, you will see an input window like this below. As you can see, it is indicated as the Terminal tab. You can type in commands in this space. Here, you type in node-version and hit enter. If the version information is displayed like this, it means that the Node.js installation we did earlier was successful. This number is the version number you received, so it just has to be not smaller than in this video. And it's not mandatory, but I'm going to install one plugin for convenience during the practice. This is a plugin that displays the files and folders to be used in the project with more intuitive icons like this. In particular, it changes these folders so that they can be more easily recognized. If you're already using something, you can skip this process. Please press this extension button on the left toolbar. Then a tab appears where you can search for and install plugins. Please search for Material Icon Theme in the search box. Please install this plugin created by Philip Keefe. Once you've pressed the install button and the installation is complete, after a while, options like these will appear at the top. You can select Material Icon Theme. There are various other icon themes as well, so you can search and install the ones you want. For color themes across VS Code, if you search for theme, you can also find various themes. The one I'm using is OneDark Pro. Lastly, let's talk about browsers, the programs we use for surfing the web. For convenience in this course, I recommend you to use either Chrome or Edge. Both can be used in Mac and Windows. You will install a plugin for React development in whichever product you choose to use. First of all, please open the browser you will use for the practice. For Chrome, enter this address to go to the Chrome Web Store. For Edge, visit the add-ons page using this address, then search for the extension React Developer Tools in the search bar and install it. In Edge, click on this button. In Chrome, click on this button to add the extension to your browser. This tool will be useful not only for the practice in this lecture, but also when you develop with React in the field. If you've followed up to here, you're all set to start hands-on practice. In the next video, we'll create our first React project. Please don't skip this video, make sure to watch it. I will quickly show you how to use the example page and how to ask questions. Please note that I don't accept questions through the platform's question function or YouTube comments. You will be able to see the link to this Notion page in the YouTube comments or on the platform. I advise you to bookmark this page. For each lesson doing coding practice, there is a linked page like this, and if you enter the page, you can see all the codes of the examples are uploaded in snippets. When you hover over each code snippet with your mouse, you can easily copy the code through the copy button that appears in the upper right corner like this. When you click this duplicate button at the top, you can clone the page to your Notion. You can study by adding your own notes and memos to the page cloned to your Notion account. However, you need a Notion account for this, which you can sign up instantly with your Google email. But note that this main page is not duplicated. You'll need to copy each example page individually. Finally, the way to ask a question. Click this comment button in the upper right corner. Then it switches to a mode screen where you can leave comments. After that, when you drag the code where you have a question, a comment button appears like this. This is where you can leave your questions. It'll help me to respond more quickly if you attach detailed screenshots along with your questions. I'm alerted by the questions posted on the Notion page, so I can check them quickly, and other students will be able to get help by seeing the posted questions and answers, so I am using this method. If there is anything that doesn't work properly in this process, or you have any inquiries or suggestions, feel free to contact me here at this email address. Hope you enjoy the course. Now, let's create a project for some serious hands-on practice. There isn't just one way to create a React project, there are several. As you can see, even the official React site provides different ways of creating it according to your needs.
Why do they make it so difficult from the start? Not even establishing one way to create it, and there are multiple ways.
React is not a framework that forms the entire structure of the front-end application. It's a library that is used by being mounted on necessary parts. Just like the CPU is a part of a computer, React is also just one of the important components that make up a website. It's not the whole product. Just like how you can order a brand product, visit a computer store, or assemble it yourself to get a computer with a specific CPU, the way to use React also varies depending on the scale and purpose of the application to be applied, and other technologies to be used together. If you develop a web application of a certain size, or larger in the field, you will probably study a framework based on React like Next.js and use it. In this lesson, we are going to create a project using Vite, which is a commonly used method today. Vite is like a service that quickly assembles and delivers a simple computer. It's most suitable for quickly creating and practicing React projects. If I get to create Node.js related content in the future, we'll also delve into these tools in detail. Now we will begin the hands-on exercise. First, create a folder where your practical projects will be located. This folder will contain the projects we're going to work on. Those familiar with terminal programs, please open the terminal in the location of this folder. For Windows, you should use PowerShell here because Git Bash may malfunction in this part. If you have difficulty using the terminal, you can use VS Code. First, please launch VS Code like this. On the first screen, there will be a Open button for Mac and Open Folder button for Windows. Click on that and then open the folder you just created. If you look at the menu bar at the top, there should be a menu called Terminal. Click on it and click on New Terminal at the top. Then a command input window like this will appear at the bottom of VS Code. When you open the terminal in VS Code with a specific folder open, the terminal opens in that position. It doesn't matter if this terminal design is different from the video, so you don't have to worry about it. This blue arrow-like thing is the result of me applying a kind of skin to the terminal. Now I'll type commands here to create a React project. Please enter this command. This is a command to create a new project using Vite. If Node.js is a smartphone, you can think of the npm at the beginning as something like an app store. It installs and manages various tools necessary for development, and also performs a variety of tasks related to the project. It tells npm to create a project using a tool called Vite. This part is to explicitly use the latest version of Vite. Now let's run the command. Once you hit enter, you will soon see a prompt asking for your project name, like the sample shown here on the right. You can type any name you want for your project. You can type it right away without hitting backspace. Since this is our first project, I will name it like this. Once you hit enter, you will be shown a list of libraries and frameworks that you can choose from, and you can select using up and down arrow keys. Of course, we will choose React. Now we're going to decide which language and tools to use for this React project. In this tutorial, we're going to use pure JavaScript. Then you'll see a message that the project creation has been completed, like this. Now, if you look at the Explorer screen on the left side of VS Code, you can see that a new folder has been created like this. You can also see this newly created folder in Finder or Explorer. Now, close this VS Code window and restart VS Code. From the VS Code's initial screen like this, click on Open Folder again. This time, please select and open the newly created folder. In other words, open the newly created folder that is inside the folder you opened earlier. Now, our first created project has been opened. You can see what's inside your project folder from the Explorer on the left like this. If the Explorer isn't open, click on the top button in the left toolbar. Clicking the foldable folders like this will unfold them like this so you can see their contents. As you can see, there are many files and folders from the start. You could say Vite assembled the computer and sent it to you with these components.
You mean there would have been a difference in the setup if you created the project in a different way?
Correct. Although there would have been a commonality in considering React as a core component. Now, let's take a look at the files. There are HTML and CSS files you might have already coded, and there are also files in JSX format created like this. You won't really need to modify these files in this class. I'll briefly explain what each of them is. In this way, you can click on each file, review its content, edit and save it. Those of you who have learned Git will know what a .gitignore file is. Simply put, it's a list of files that you do not want to add to the time capsule when saving the stages of a project. It contains files that automatically generate, so don't need to be included, or files that must be excluded due to security concerns. This file is a configuration file for a tool called ESLint, which helps with JavaScript coding. You can think of it as settings for a spell checker in a word processor. Package.json is the configuration file for the project itself. In fact, you could say that this file is in the topmost folder of pretty much all Node.js based projects. The README file is a user manual for this project. The last file is the configuration file for Vite that was used when creating this project. We've covered enough about these files. Let's now prepare to run this project. With just this structure Vite assembled for us, we cannot run the React application, because the libraries we need for development and running, including React, have not been installed yet.
So it's like the computer is assembled, but it hasn't yet installed the operating system and programs, right?
Correct. Let's revisit this package.json file and look at the section below. There's a list of libraries to be installed like this on the right. The upper part lists libraries that will be used when the application runs, meaning when real users use this web page. And the bottom part lists libraries used in development, such as testing or build process. For now, only this list has been compiled. Now let's go and download them. Please open the terminal again and type npm install, or short for npmi in here. This is a command that downloads the libraries listed in the package.json file into this project. After typing, I will press enter. As you can see, it consumes some time, and you can see something progressing. And then, if you look in the Explorer, you'll see that a folder called Node Modules has been created like this. And if you expand it, you can see that there are many folders inside, as you see. Inside each, there are also various files and folders. Like this, using a package manager, such as npm, to download necessary libraries to the Node Modules folder is practically a necessary process that all Node.js projects go through at the start. With this, we are now ready to run this web application. Next time we will explore how the React project operates by running this project. Let's look at how to use it by running the React project we created last time. Open the project like this using VS Code. First, open this file called package.json. In this JSON document, you have an item called scripts like this. And for each item, there are string keys like this. These represent frequently used commands in this project. In other words, the contents here will vary depending on what type of Node.js project it is. Since we won't be dealing with lint in this lecture, we'll look at the remaining 3 commands. These commands can be used in the terminal, just like the ones we practiced in the last video. In the last video, I referred to programs like npm, which are compared to the App Store as package managers. If you choose to use npm from package managers like npm and yarn, you prefix commands with npm run to execute them. If you are using yarn, you prefix commands with yarn to execute them. Since we'll be using npm in this lecture, we'll be using such commands. Now let's understand each of these commands by comparing it to the process of developing a sandwich menu. First, dev is used literally for the development process. Just like trying out various stuff in your sandwich and tasting while developing the menu in your kitchen, you develop a web page by checking how your written code is reflected in real time. Build is similar to packing a completed sandwich for sale. It compiles the codes into files that will be uploaded to the server and distributed as web pages to the users. Lastly, preview is the process of unwrapping and testing the prototype packaged through build. It's to check the build files one more time before deploying them. Now I'm going to execute these commands. This section got too lengthy, so I changed the project path. It's different from the last video, so I thought I'd mention it in case you're confused. First, let's try giving the command to start development mode. Enter the dev command, preceded by npm run. Then, you can see something being executed and these messages popping up. Like this, the address of the localhost 5173 is displayed. It suggests to press H and enter at the same time to get help. If you press these 2 keys together, all commands that can be given in this state are displayed. It tells that you can command to restart the server, show the server's URL, open with the browser, clear the console, and end the development status with the key combinations on the left. The command we'll use most often is the one that allows us to preview the web page we're developing in a browser. Let's press O and enter together. As you can see, this opens the web page in your computer's default browser. If it opens in a browser like Safari, not Chrome or Edge, you need to change your computer's default browser to Chrome or Edge in the settings. Let's look at it with the code. You can see that the codes pre-generated by Vite result in the same output as seen on the right. It's a simple example setup to give beginners some initial hints. As you can see, if you click this button, it is even programmed to increase the number. If you look here, it says to modify the app.jsx file in the src folder and test it. Just like this, open the file and scroll down to find where this h1 element is. The line in the code generated by the version of Vite used in the video is line 19, but it might be different in your code. Then, after replacing the middle plus sign with the text plus and saving, you can confirm that it's immediately reflected on the web page on the right.
How can the content of a web page change without any refresh? Is computer haunted?
HMR stands for Hot Module Replacement, a technology that reflects code modifications without refreshing the page. This dev feature allows you to develop while checking the results of code modification in real time. Now press H and enter together again to see the commands. I'll try closing the development feature by pressing Q and enter. And then, if you refresh the page, you can see that the site is no longer appearing like this. The development server has been shut down. This time we'll try issuing the build command, which we liken to the task of packing a sandwich. It's the process of creating files for deployment on the server. I mentioned that during development, we write code like this with JSX, but to work in a user's browser, it needs to be converted to JavaScript. We'll also put npm run in front of the build command and give it a try. Press enter and wait for a moment, and you'll see that a new distribution folder like this is created. If you open it, you can see it contains these kinds of files and folders. You'll notice that it's composed of HTML, CSS, and JavaScript documents. This folder is the packed sandwich. It's uploaded to the server to be displayed to users. Now, we're going to proceed with what is akin to tasting after unwrapping the preview. Essentially, it's about opening this folder on my local server that is for trial runs. Type in npm run preview. When pressing enter, you will see a message like this displayed. This time too, an address will be displayed, but you can see that the last number differs from the developer's page on the right. You can check the commands here with H and enter, and execute the command to open in the browser with O and enter. This time, you can see that the web page opens to an address ending in the number 4173. This is the result of running a prototype made for distribution.
But what is this localhost and 40173 in this address?
Yes, let's take a brief look at this address. Finally, this localhost before the colon generally refers to my computer. If we were talking about buildings, it would be our house. To be precise, it means the computer on which this program is running. The localhost is set to refer to the address 127.0.0.1 by default. If the above address is the absolute coordinates pointing to my computer, you can think of the localhost as a signpost stuck in there. The number after the colon is called a port. It's like the door number of the building that the previous address is pointing to. Since the same server can perform various services like web services, backend services like Spring, MySQL databases and so on, they are set to be accessed through their respective assigned ports like this. In this project, port 5173 is set to be used to check the web page being developed in real time, and port 4173 is used to test the build result. We looked at how the development mode of this project is run and how the build and inspection process proceeds. Next time, we'll look at the codes one by one and understand how React works. Now, let's look at the components of the project and see how React works. We will use the project we practiced in the previous video. Enter developer mode using npm run dev command and press O and enter together to open the browser. I guess I don't have to mention this process in the future. During coding, you can close the terminal window below by clicking the X button on the right. When you need to enter a command again, you just open the terminal tab again as you learned before, and select this terminal where the Node.js command is running. We'll look at the codes of this project and see how the executed web page is implemented. Let's first open this index.html file. As you can see, it contains very basic content. Especially you can see that in this body tag, there is only one div.
So it's just a page with nothing on it, right? How can such a page be created with such codes?
Let's take a look at this page together. If you right-click on the blank space of a web page, there should be a view page source or a similar menu towards the bottom. Click on it. Then a source view tab like this opens. You see, there's added content at the top like this. You can guess that Vite serves the index.html file, not as it was written, but processed in a predefined way. And inside this body tag, you can see there's still just one empty div. This time, let's take a look at the developer tools. You can open the developer tools in Chrome and Edge by pressing this shortcut key. Just press the shortcut key that corresponds to your operating system. If you develop for the web, you will inevitably use this feature. Please make sure the Elements tab is selected in the top menu bar like this. Here, you can look at the DOM, which is the rendering result of the web page. When you hover your mouse cursor over each element, you will see that the corresponding element is highlighted like this. you can expand the div in the HTML code, which was empty, to see it is composing the component displayed on the right screen with different elements like this. The fact that there are elements in the DOM that were not in the HTML document means that they were dynamically created and inserted by JavaScript. Now let's get back to the code. At the bottom of the index.html file, you'll see it's loading the main JSX file located in the src folder like this. This is the file. Let's open it up and take a look at the code. As you can see, this is a code written in a syntax called JSX, which seems like a mix of JavaScript and HTML. Actually, this JSX extension has no functional difference from the JS extension. It works just fine with the JS extension as well. However, it is conventionally used because it is easy to tell that this document is React code written in JSX syntax. There's also the advantage that editors or IDEs can display it like this, with a React icon. We'll delve into these codes in detail in the next video. For now, let's focus on this part. If you've learned JavaScript, you'll recognize this as a code that selects an element with the ID root from the document. It's this dv element right here. It's being executed as an argument to a function called createRoot. And then you run this render method on the result. Although you haven't learned about JSX yet, you might guess that it's the code which makes these elements to be rendered and enter into this dv. You can understand why there were DOM elements in the div that was empty in the code. Then, what would be this element called app inside there? If you look at the top, you can see that it has been imported from the app.jsx file in the same directory. A JavaScript object imported from another document is being used like an HTML tag. Let's also open this app.jsx file. Obviously, you can see it is written in JSX syntax.
I see that CSS files and image files are also being imported like this.
Yes, it's impossible in pure JavaScript, but they are loaded as specific data converted by tools like Vite, and it's used as needed in component code like this. You will soon learn more about this in the upcoming videos. Now let's take a look at the function named app below. This entire thing is a function called app. In React, such functions serve as components. The first thing that distinguishes a function as a component is that the name of the function starts with a capital letter, and the second thing is that it returns a tag written in JSX like this. You can see from this part of the code that it isn't a JavaScript file. You can see that the elements you saw in the developer tools a while ago are written right here. These go into the spot in the main JSX on the right as the component called app, and as we have already seen, app gets rendered into a div tag called root in the index.html and appears on the screen. You should have a rough understanding of how React works by now. Now let's look at the compiled results after development. In the Terminal tab, you can open another terminal by splitting the window like this by pressing this button. Here, if you enter npm run preview, the command we learned in the last video, you can make the development server and the preview server run at the same time. I will also open the build web page in the browser like this. You learned in the last video that this distribution folder is the result of the build. If you open the index.html document, you'll notice that the code is slightly different from the document of the same name we saw earlier. The code loading the main JSX document is gone. Instead, you can see that it loads these CSS and JavaScript files from the assets folder. You can see the same code, even when you open it with view page source in the browser. In other words, this HTML file is what opens on the deployed website.
But why are these weird characters attached to the file names?
The main reason is to change the names of the modified files when the web page is updated. If the name of the file remains the same, it might use the cached content unknowingly, even if the content has changed. If the names of the files to load change, every time they are loaded, the updates are immediately reflected. If you open this JavaScript file, you'll find that the code written is very long and not user-friendly. It gets compiled into this compressed code without indentation because it's not for people to read anyway. Files such as modules including React, as well as JSX documents written by developers, are bundled into this JavaScript file and utilized. In the case of CSS documents, the two below are also written by the developer. You can see that in the distribution version, it is bundled into such a single compressed file. A build operation like this includes a process where the computer compresses the particular web page into a form best suited for efficient execution.
But looking at these two images, one is in the public folder and the other is in the assets folder inside the SRC folder. What's the difference between the two?
The elements in the public folder are distributed as is, and you can consider that the elements in the SRC folder go through optimization and other processes by the bundler. You can see that the name has changed like this. Generally, static files that are not confined to specific components, such as favicons or global configuration files, go into the public folder. Elements used in components go into the SRC folder. You can think of putting them in the SRC folder for the most part. So, we have explored the basic structure and functionality of a React project like this. Starting from next time, we will get to know how to develop with React in earnest. Now, we're going to program a React application. First, we'll remove the sections that Vít put in as examples when creating the project. Open this app JSX file. Going forward, I'll just call documents that start with a capital letter and have a JSX extension components. We'll remove most elements from this app component and create an empty component. I'll modify the code like this. I left only the code that returns null to the app component and removed all other elements and import statements, etc. If you run the development mode in this state and open the page in the browser, you will see a blank page like this. And you can see that this div, where the app component was, is empty. You can tell that nothing is rendered if the component returns null. If you write the part where null goes in like this, the result that appears on the browser is the same. We call this an empty fragment, which you will learn soon. This time, we are going to delete unused files. Please select and delete the distribution folder and image files on the left, along with the app CSS files. It's not a problem if they remain, but this is to start the project with only the necessary files. So, let's make it look like this in the end. This is not a necessary step, but we proceeded to let you know what unnecessary elements are. In actual practice, we would have deleted or emptied this index CSS file, but we will just leave it here. As you can see, it is being imported and used in main JSX like this. CSS files imported in this way are applied globally throughout the application. Since the global style written here is not bad, let's just use it as it is for now. Now we're ready to start writing practice code for this project. Before we get into the actual practice with components, let's take one last look at this code from main JSX. Let's start with this import part. For those of you new to Node.js programming, this kind of code might seem unfamiliar. If you've been studying JavaScript, you would have learned about object destructuring. When you have an object like this, you can extract only the properties you want by assigning them to constants or variables surrounded by curly braces like this. The name constant gets the value of the property with the key name, and the age constant gets the value of the property with the key age. So when you print out name and age to the console, you would get a result like this. You can also use this destructuring when importing features from other modules. Like using only the addition and subtraction functions from the module above, it's to use only what you want among the numerous features the module has. If you open the Node modules folder, you will see that it contains many such modules, including these two modules listed on the package JSON installation list. We will import these two into main JSX. However, we're going to use only a part of the many features in each module. So, in this kind of code, we take the tool called strict mode from the React module, and we take the function called createRoot from the module called client inside React DOM. The createRoot function is a feature introduced in React version 18, so those who learned React before this might be a bit surprised. It is used for faster and more efficient rendering, and is applied at the topmost root element of the app like this. Strict mode is a function that warns about potentially problematic or deprecated codes during the development process.
The content is about components, but isn't the introduction too long?
That seems to be the case. Now, let's get to know about the components quickly. I mentioned that React's components are elements of a web page divided into reusable units. This app is also a component. It uses the naming convention in camel case that starts with a capital letter. Although it's empty now, it returns the element to be rendered. It can be imported somewhere else and used in such a manner. Let's modify the code while looking at the web page together. A component should return elements to render in this way using JSX. In developer mode, if you modify and save the code like this, you can see it reflected immediately on the web page, as you can see on the right. Each element must have an opening tag and a closing tag, just like this. Each component has a root element like this, and it can only return one element. If you return more than one top-level element like this, you will see an error like this.
So, for rendering those two elements, I have to wrap them in an empty div or span, right?
That's possible, but it could create unnecessary DOM elements, and problems related to div styling may unexpectedly occur. In this case, you can use the fragment we learned earlier. It allows you to group and return child elements without creating additional DOM nodes. This time, let's try to separate this element into a different component. Let's draft a component named hello in this way. I've repeatedly told you that it must start with a capital letter to be recognized as a component. If the name starts with a lowercase, an error will occur. You can see that this element does not get rendered on the web page. If you open the console tab in Developer Tools, you will be able to see a warning message that it can't recognize the hello tag that starts with a lowercase. Let's correct it to uppercase to allow it to render properly. If you can write the elements to render in one line like this, it will be cleaner to put it right after the return statement. On the other hand, when you need to write in multiple lines like below, it is better to write it in a readable way by surrounding it with parentheses. A component that fulfills the basic requirements can be used in JSX by using its name as a tag name, like this. Because hello is used within app, app is the parent component, and hello is the child component. In this way, small components to be used in a specific component can be written in the same file like this. However, if the size of the component grows and it can be used in other components, it would be better to separate it into its own file. Create a new child component file in the same folder as app, and please write your component code like this. This is a component that renders such text within a p tag as the top level tag. And don't forget to do such export so that it can be imported elsewhere. Now, you just need to import it in app. Please write the import statement at the top of the app component document like this. Bundlers like Vite usually set it to omit extensions such as JS and JSX. And just like hello, when you insert this component like this where you want it, you can see it successfully displayed on the web page like this. Lastly, let's look at the 3 ways to write a React component and wrap up this video. Please write as I've done in this document. Like this, I wrote 3 different forms of components. The first one is a class style component, which was used in the early days of React. If you look at old React projects, you can find codes written in this class style. We make and use a class that explicitly extends from a class called component. And you can see that the element to be rendered is returned in the render method of this class. The class style components are not often used these days. Nowadays, people are increasingly using functional components as they allow for more concise coding, superior performance optimization, abstraction, and reusability. You can see that both of these components take the form of functions. One of them is the standard function type of component that we used in other components. The other one is a component, written in the style of an arrow function. Recently, it's becoming more common to use arrow functions as they are more concise and free from the issues of this binding. Later on, when we'll handle topics such as React hooks, we'll get to know them in a more detailed way. Now, after exporting all these components, we're going to wrap up this practice by importing and using them in the app component. In this way, we've learned the basics of components. Before diving deeper into components, we will start with learning about JSX from the next video. Now, let's learn about the JSX syntax. Please create a new project as you learned in the previous video. You can name your project whatever you like when you create it. And in this project, I left this part of the code in the app CSS file, rather than deleting it. I did this because it looks better when elements on the web page appear in the center. And if you import it in this way in app component, the style is applied globally. Soon you'll see other ways to apply CSS. In this video, we'll explore the JSX syntax by writing code in this app component file. First, comments in JSX are written in this format. If you wrap the ends like this, it is recognized as a comment. Actually, today's editors or IDEs toggle comments on the line where the cursor is or selected lines by pressing the Command or Control key and backslash together. So I don't really need to tell you this. Here's a principle to remember when writing tags. In JSX, one must always close the tags like this. Even for tags that are used alone, like the image tag or break tag, you should always close it with a slash like this. If even one tag does not comply with this, an error will occur on the page like this.
HTML is forgiving and usually lets things slide, but this seems a bit fussy.
Although the code may look like HTML, you should remember that it is a document that will be compiled in JavaScript. Let's take a look after writing code like this up here. You can see that elements written in JSX format are each stored as constants. This means they are transformed into some data that can be used in JavaScript. After writing the code that outputs these as logs like this, run the developer tools in your browser and open the tab named Console. You can explore the inner items of each object by clicking these arrows. There's no need to analyze each one, but you can see that these JSX elements are approximately turned into these kinds of JavaScript objects. They become basic units forming the virtual DOM. Because JSX elements are such objects to be translated into JavaScript, they require stricter syntax compliance than HTML. I'll keep these elements stored in constants for insertion into the page later. Now, let's take a closer look at brace expressions. I'm going to add these sections to the code. A curly braces expression is quite literally an expression within curly braces. An expression refers to a piece of code that returns some value, or in other words, can be replaced by some other value. Here, language is a constant that returns the string JavaScript. Because it returns a value within, and this can be replaced by the string JavaScript, this constant is also an expression. This curly braces expression containing it is rendered like this on a web page. So, you can see the text JavaScript appears on the web page like this. What do you think will happen if we adjust the code like this? As you can see, an error occurs and nothing appears on the screen. That's because the keyword hello world in this context is not declared as any variable or constant. You can check it like this in the console of the developer tools. If you want to put the string hello world inside these braces, you have to enclose it with quotes like this to make it a string. Of course, in such cases, it would be better to write it like this without braces. Anyway, brace expressions in JSX are used to render code snippets that return certain types of values on the screen. Let's find out which expressions can be used through examples. After creating a component like this, please insert it in the app. The result will be as shown on the right. You can pause the screen for a moment and look at the code. We're going to use the values in these constants in brace expressions. Using variables or constants directly in brace expressions is like the code we saw a little while ago. Expressions returning strings can be used in brace expressions. Next is an expression that adds 1 to a constant containing 25. This expression returns a number. Numbers can also be used in brace expressions. Next is an expression that adds a string to a string. This also returns a string, so it can be used in a bracket expression and rendered as shown on the right. String interpolation also returns a string, so it's also possible. The problem is this boolean. As you can see, you have explicitly converted it into a string and put it in a bracket expression. If you put a boolean value as it is, it won't result in an error, but it won't be rendered on the screen like this. That's why we need to convert it like this into a string. In other words, among primitive data types, things that can be rendered in a bracket expression are strings and numbers. Next, we're going to cover the usage of objects and arrays. Please insert this component into the app as well. Actually, if you realize that these curly bracket expressions also take values that return strings and numbers, there's nothing special about it. Let's move on quickly. In case of objects, you access the values via keys like this. As both return strings, you can see the result like this on the right. You access the arrays via indices like this. The return string is also rendered. If you access the length property of the array, the size of the array is returned as a number. Therefore, this also appears successfully on the web page. Below are strings returned as the result of the array going through a mapping or filtering process and then joining. If you've learned JavaScript's functional methods, you'll be able to read this easily. Those who find this section difficult can skip it for now. We'll go into more details on rendering arrays soon, and we'll also cover mapping and filtering. Here are some examples of function call statements. Please insert this component into the app as well, so it appears on the web page as shown on the right. These are simply executing functions that return strings or numbers too. As such, the result of executing a function that returns a string is rendered and displayed as shown on the right. The two lines immediately below are also getting values from the declared functions. Moreover, it is also possible to create and execute an anonymous function within the curly brace expression like this.
So, all JavaScript expressions that return strings or numbers can be used, right?
Yes, that's what I'm trying to show you through these examples. Here's your last example. You remember how we stored JSX elements in constants at the beginning. These JSX elements can also be used in curly brace expressions like this. So now you can see the rendered results on the web page to your right. In the next video, we will learn about ways to write JSX utilizing this point. We will continue in the next video. Following the basics of JSX syntax we learned last time, in this tutorial, we will look at conditional rendering and list rendering. As I mentioned in the last example of the previous video, JSX elements can be used in a curly brace expression like this. This means that an expression that returns a JSX element can also be included. Of course, putting just one element like this won't be much different from using it without braces. Let's now see how expressions that return elements can be usefully applied in JSX. Please write the code like this. First, we have such constants that store Boolean values. In real work, state, which we will learn later, will be used. And below, code is written using a ternary operator like this in expressional braces. If you have learned any programming language to the basics or more, you would be familiar with the ternary operator. This entire ternary operator syntax represents an expression that returns one of the values on either side of the colon, depending on the value in front of the question mark. If a true or a value treated as true comes in front of the question mark, the value in front of the colon is returned. If a false or a value treated as false comes in, the value behind the colon is returned. Understanding the content of this bracket expression will not be difficult once you get it. If the value in the preceding constant is true, the element written before the colon is returned and rendered. If it's false, the element after it appears on the screen. By changing and saving the constant's value for testing, you'll be able to see the rendered result changing on the screen. It can also be applied to larger elements. Let's add a code like this below. I told you that if a JSX element becomes longer than a single line, you can write it in brackets like this. You put fragments that contain multiple elements inside these brackets. With this question mark and colon, you can tell this whole code is one ternary operator. If the value of the constant is true, it returns the fragment in the front like this. If it's false, it renders the one from the back. Let's look at one more example of applied code. Here, we wrote a call to a function that returns JSX elements in a curly braces expression. This function takes a string as a parameter as shown. This can be replaced with components used with props, which we will learn about later. Ternary operators can be chained together like this to write two or more equivalent levels. If the passed argument is admin, it returns the first fragment like this. If member is passed, it'll render the next element. If any other value is input, it renders the last element. In this way, you could apply the ternary operator to implement conditional rendering in practice. Next, I will show you how to use the AND operator. Please write the code like this. We have two constants at the top. In this curly brace expression, there is an AND operator between the Boolean value and JSX element. If the preceding value is true, the element that follows will be rendered and appear on the screen.
But isn't the AND operator usually used to return true when both sides are true? How can it be used like this?
Open the developer tools and then the console tab. Write this code and press enter. As you see, hello is returned. A string with a non-zero length is considered a true value or truthy. The opposite is called falsy. In JavaScript, when there are truthy values on both sides of AND, the latter value is returned like this. Since the returned value is also truthy, it works without any problem in condition statements as well. This principle is applied so that if the preceding value is true, the following JSX element is returned and rendered on the screen. If the preceding value is false, false is returned so it doesn't appear on the screen. As we learned in the previous video, Booleans aren't rendered. Let's take a look at other codes that make use of this. Write the following code right on the next line. The string preceding the AND has a length not equal to 0, so it's truthy. Therefore, if the message is not empty like this, the following element containing it is rendered. On the other hand, if it's an empty string, we can see that it doesn't get rendered. The same applies when it's null. Then, you might expect there to be an operator that works in reverse. I'll write some code like this for you. Above, the null coalescing operator is used, and below, the OR operator is used. If null or undefined comes in front, both operators return the value that comes after. If any other falsy value comes in, only the OR operator returns the value that comes after. You have to remember this difference. The null coalescing operator only takes effect when the value preceding is either null or undefined, whereas the OR operator returns the following value if any falsy values precede it. And you can see that it returns the value as is when a truthy value comes in. So, these operators are often used to provide a default value when a specific value is empty or null. If you remember how to use them well, you'll be able to implement the features of a web page with concise and efficient code. Now, let's move on to the next topic, list rendering. I'm going to write code like this. Array can also be put in the curly bracket expression as this. If so, it renders only the renderable ones among the elements in the array. Therefore, in the case of this array, you can see that only numbers and strings were rendered, and booleans didn't appear on the screen. Then, you might guess that JSX elements can also be put in this array, because JSX elements are also rendered on the screen. So, if you put button elements separated by commas in the array, in the curly bracket expression like this, you can see that the 3 buttons are rendered on the screen. You can capitalize on this quite efficiently in React. Please write a code similar to this one. There is an array of strings at the top. If you look at the code below, the code for inserting the list item elements is written in just one line. But if you look at the web page and developer tools, you can see that it is rendered into 3 elements like this. The set of strings in the array above has been made into list item elements. Those who are familiar with the concept of array mapping would likely not have a difficult time guessing how this works. Let's presume we have an array like this. In JavaScript's array, there's a method called map. The map method takes a function as a parameter that receives an input and returns a processed output. This function, in this case, takes an input, multiplies it by 2, and returns the result. And it creates a new array with the result of each element of the array after executing the function. So, an array with the results of multiplying each element of the original array by 2 is returned like this. So, how about we insert a function that returns a JSX element with the parameter value placed in a p tag this time? Like below, the number of p tag elements in the array will return as an array and will be rendered on the screen. Hence, you can see results like this. This process is called list rendering. It's the result of rendering a new array, where each string in the array is wrapped with list item tags. When rendering a list, you should set an attribute like this, called a key, to the elements that will be repeated. It's like React quickly figures out the changes in the list by tagging each element. Therefore, you should put a unique value here that does not overlap with other elements. In this case, the index of the array has been used. If you put a second argument in the function that goes into the map method, it becomes an array index, starting from 0. Therefore, if you add this to the element, you can see that it is rendered from 0 like this. However, this array index is only used when there is no other way to distinguish the items in the array. Because when items are added or deleted, this value also changes, so it may be inefficient or prone to errors in places with frequent changes. In the next example, we will solve this. But before that, let's learn about the feature called array filtering. The filter method, like this, accepts a function as a parameter that returns either truthy or falsy. And it returns a new array that contains only the elements of the array that return true when the function is applied. This function returns true when the given value is even. So you can see that an array with only 2 and 4, which return true, is returned. If you map it directly to this, each element will be converted into a p tag, and an array of p elements will be created just like this. Now, we will take a look at examples that apply what we learned in this video. Pause the video and take a moment to look at the code. First, we have an array of objects like this. Each one contains information about a book. The items are the serial number, title, whether it's published, and the name of the publisher. These objects each have a unique number like this, so we won't have to use array indexes in this example. The constant below contains the results of filtering the above array. I put in a function that returns whether the book's publication status is true as an argument. Therefore, this array will end up containing the first and third books that are in the published state. Now, we will examine the part that is being rendered. If the length of the filtered array is 0 or more, you can easily see the code that renders the H2 element like this. Next is list rendering. As expected, you can see that book number 1 and book number 3 have been rendered through filtering. As I mentioned earlier, because these objects have unique numbers, you can use them instead of array indexes in the key attribute. This time, let's change the publication status of all books to false. There should be no books in the array below. Because the length of the array is 0, this H2 element will not be rendered. And in the case of the ternary operator below, the latter one is returned, and you can see that it is rendered as on the right. This is because 0 corresponds to falsy in JavaScript. In this way, we have learned about conditional rendering and list rendering through examples. We will continue to learn about JSX in the next video.